Hello, year threes! How are you doing? Well, I hope. Mr. Morrissey here with another problem of the week! Yay! Now, can you remember what we did in our last lesson? It was about equivalent fractions. We were looking at what equivalent fractions are and how you describe them. So how would you describe what an equivalent fraction is? What would your explanation be? Well, we saw that equivalent fractions are fractions that are worth exactly the same amount, but are written in different ways. We're going to keep focusing on them today. Today, we're going to look at seeing if we can discover a rule for finding equivalent fractions. So there is a rule that allows you to make equivalent fractions. I'm not going to tell you the rule until the very end because it's so much more powerful if you can discover mathematical rules by yourself. So by looking at the examples that we go through and searching for patterns, which is what maths is all about, searching for patterns, can you discover the rule for creating equivalent fractions? That's the challenge. Now, in the last video, I recommended a great activity, which is make your own fractions wall. And it's amazing for finding equivalent fractions. So if you haven't done that, I recommend you do it, and I'll leave a link again in the description below. We're going to get started. I've got some strips of paper here. In fact, let's start off by looking at these three. Now, can you see that they're all the same length? That means the whole is the same, and that's very, very important. When you're comparing fractions, the whole has to be the same, so you can compare them. And the first thing I'll do is I'm going to fold each one like this. So can you see what I've done? And if I open it up again, can you see what I've done? What fraction have I folded the whole into? Well, there's two equal parts, isn't that right? So each part is a half. And I'm going to do the same for the other two. So I've got three holes, three strips of paper, which are exactly the same, and I folded them all into halves. Now I'm going to do some shading. Okay, all done. I finished my shading. Can you see what I've done to each strip of paper, to each hole? I've shaded one of the two equal parts, so I've shaded one half. So do you accept that I've shaded one half of each of these strips? Excellent. Now I'm going to do some folding. I'm going to take one strip, fold it in half, and fold it in half again. Now what's that the same as when you half and half again? How many parts will I have? I don't know if you can see, but there's 4 equal parts. I'll put in some lines. Can you see the 4 equal parts in total? How many are shaded? Yes, 2 out of the 4 are shaded. So what fraction is that? It's 2/4. Let's compare it to our original half. Can you see that they're exactly the same? So what equivalent fractions do we see? A half is equivalent to 2/4. We'll do one more. This one I'm going to fold in half, and in half again. What's your prediction? How many equal parts will we have this time? It's 8. I'll put in the lines. Can you see the 8 equal parts overall? And can you see the 4 of those parts that are shaded? So what fraction is shaded this time? It's 4/8. Let's compare it to our other fractions. What can you see? What equivalent fractions can you see? A half is equivalent to 4/8. And 4/8 is equivalent to 2/4. Now, one reason why I've done this with the strips is because you can do that at home to help you explore, investigate, and understand equivalent fractions really well. So let's have a look at this. What have we discovered so far? So this we know is a half. And these we know are each worth 1/4 of the whole. And these are worth 1/8. So can you see the equivalent fractions there that we just saw in those strips of paper? What can you see? What can we write? So we can say 1/2 is equal to 2/4. And we can also say 1/2 is equal to how many eighths? It's 4/8, isn't that right? But we can also compare the quarters and the eighths. So 2/4 is the same as 4/8. Let's look at the two other strips with the yellow parts shaded. What fractions can you see there? What equivalent fractions can you see? What fractions can you see here? Well, there's 3 equal parts and 1 is shaded, so this is 1/3. This is 1/3. This is 1/3. And what about here? How many equal parts has the whole been split up into? 9. So one part is worth 1/9. Each of these parts is 1/9. Now look carefully. What equivalent fractions can you see? Get you started. 1/3 is equivalent to how many ninths? Can you see? Look. It's exactly the same as 1, 2, 3 ninths. So 1/3 is equivalent to 3 ninths. So we've got 4 sets of equivalent fractions. Remember here we're trying to discover a pattern, find a rule for creating equivalent fractions. So what patterns do you see? Have you spotted any yet? Well, keep looking. Don't give up. Here we have a fractions wall. And as I said before, they're amazing for finding equivalent fractions. You can just look for fractions that are exactly the same size, that are worth the same. And the more pairs of equivalent fractions you find, the more likely you will be able to discover the pattern and then find that rule. So if you can create loads and loads of pairs of equivalent fractions and then see if you can discover what's going on, I bet you can find the rule. Now, if you do make your own fractions wall, like I recommend, using strips of paper, it's great because you can move the strips around and put them on top of each other to find fractions that are exactly the same. So if I had this as a piece of paper, this 1/4, I can move it around and see what's it exactly the same as. Is it the same as 1/6? No. It's bigger than 1/6, but it's smaller than 2/6. They're not equivalent. Okay, it's not equivalent to 1/7. It's bigger than 1/7. It's smaller than 2/7. No equivalent fractions there. But ooh, it's actually exactly the same as 2/8. So 1/4 is equivalent to 2/8. And there's another one. If I keep going down, I'll find another one. Can you spot it? Can you see it? It's not the 11s, even though it's close. Look, 1/4 is smaller than 3/11s, but 1/4 is exactly the same as 3/12. And once you find a pair of equivalent fractions, write them down. Add them to your list. So we've discovered 2 more. We've discovered that 1/4 is equal to 2/8. And we discovered that 1/4 is equal to 3/12. 2 more equivalent fractions there. Are you beginning to see the pattern now? Can you create your own rule? You could start it to find equivalent fractions. You ... I'm going to leave that with you for now and then hand you over to these independent tasks. Now for the first one, you can see that the shading in has been done for you. And for the other ones, you should do the shading in yourselves and then complete all the blanks and the sentences. And then number 2 over here, complete the statements, use practical equipment or strips to help you. So strips of paper might be the best thing for you to use, or you could draw representations a little bit like in activity 1. Then some problems to go a bit deeper. Number 1 is an always, sometimes, never statement. Is that always true, sometimes true, or never true? And you have to prove it. And in the second one, Alicia has made that diagram. She makes a statement. Is this possible? Explain why. I'm going to go through the answers in a moment, so pause here if you need to go through those yourself. And here are some of the answers for the first set of questions. In here we have 1/3 is equivalent to 3/9. So in words, 1/3 is equivalent to 3/9, or of course it can be the other way around. In the second one, we can see that 1/4 is equivalent to 3/12. So here 3/12 is equivalent to just 1/4. And then in the last one, 4/12 is equivalent to 1/3. And then you can write that in words here. Either way around is correct. 4/12 is equivalent to 1/3, or 1/3 is equivalent to 4/12. And then in number 2, I've completed those equivalent fractions. And here's possible answers to the problems. Always, sometimes, and never true. Well, as it says in the explanation, you can always find an equivalent fraction by doubling the numerator and the denominator, but that is not the rule we're looking for, because that's not the only way of finding an equivalent fraction. So you'll miss some if you only double the numerator and the denominator. And then in the second one, there's an explanation there. It does depend whether Alicia is thinking about the shaded parts or the unshaded part. Finally, we're going to talk about that rule for finding equivalent fractions. Did you find your own rule? Did you discover a pattern? I'll give you a final clue if you need it. Compare the numerators and the denominators in equivalent fractions. What do you notice? What patterns do you see? Do you see anything? So let's see. How do you get from 1 to 2? Now we are thinking about equal parts. Which operations use equal parts? It's multiplication and division. So let's think about multiplication here. How do you get from 1 to 2? Times it by 2. And how do you get from 2 to 4? Times by 2. What about the second one? How do you get from 1 to 4? Times by 4. How do you get from 2 to 8? Times by 4. Are you seeing it now? What about here? How do you get from 2 to 4? Double 2 makes 4. How do you get from 4 to 8? Double 4 makes 8. And finally, how do you get from 1 to 3? Times by 3. And the denominators? Times by 3. So do you see that each time we've multiplied the numerator and the denominator by the same number? That's our rule. So my version of the rule is, to create an equivalent fraction, you multiply the numerator and the denominator by the same number. That's it for this lesson. I hope you enjoyed it. I really hope you discovered those patterns for yourself and were able to come up with the rule, because that's a really powerful thing. And when you can do that, it feels really good too. I'll see you next week for another problem of the week. In the meantime, take care. Bye.